Let's consider the oxidation of alcohols. And the type of substance produced by the oxidation of alcohols will very much depend on if you've got a primary alcohol, secondary alcohol, or a tertiary alcohol, because primary alcohols, remember, are oxidized to form aldehydes, which can further be oxidized to form carboxylic acid, whereas those secondary alcohols will go on and produce ketones. And then the thing about the tertiary alcohols is that they're not easily oxidized. So I like to kind of use this basic flow diagram just to remind myself, okay, the primary alcohols will first of all be oxidized to aldehydes. They can then be oxidized to form carboxylic acids. In order to enable that further oxidation, you're going to need the reaction condition of heating under reflux. Secondary alcohols are oxidized to form ketones, and those tertiary alcohols will not easily be oxidized. So we're going to look more carefully at some of the required practicals. So the oxidation of ethanol, which is a primary alcohol, to form the aldehyde ethanol. So there's our primary alcohol, ethanol, and our aldehyde ethanol. Be aware of those functional groups for me. So what's our method to do this? Well, you're going to use distillation. You're going to need to remember the reactants are sulfuric acid and potassium dichromate 6. So these are going to be mixed with your primary alcohol. So if we go over a simple method, our mixture is going to be heated. If we take our ethanol, this represents our oxidizing agent, which is potassium dichromate 6, produces ethanol, our aldehyde. Notice the state symbols. I'll just label these quickly. So there's your ethanol. Here's your ethanol. Now the ethanol that forms vaporizes as soon as it's formed and is distilled off immediately. And why is that? Well, it's to prevent further oxidation to form the carboxylic acid, ethanoic acid. I just want to show you a diagram from our beautiful revision guide that's available on the website. So a few things to notice with the apparatus. First of all, the water bath is used as opposed to a naked flame because that ethanol alcohol is highly flammable. We have anti-bumping granules present in the pear-shaped flask to prevent very large bubbles forming, which would potentially mean that the mixture boils over and contaminates our distillate, which is in this case the ethanol aldehyde. Here's the condenser with cold water running through it in order to help that ethanol turn from a vapor back into a liquid. Notice the colour change, and this is commonly used to differentiate a primary and secondary alcohol because you see a colour change from orange to green. Now we want to talk about the oxidation of ethanol to ethanoic acid. So we're going from that primary alcohol to a carboxylic acid. So the name of this method is reflux. So the key thing to notice here is that it's an excess of acidified potassium dichromate 6. And that's going to be mixed with the ethanol. The method point you need to be aware of is that this mixture is heated gently under reflux. But what does this heating under reflux really mean? Heating under reflux basically means that none of that ethanol that's produced escapes. It's effectively forced to stay within the round bottom flask until all of it is oxidized to form ethanoic acid. So in terms of the stages of oxidation, you go from ethanol to ethanal to ethanoic acid. So that takes you from your primary alcohol to your aldehyde to your carboxylic acid. Here's the structural formula of ethanol, your oxidizing agent to form ethanoic acid and water. This ethanoic acid is separated from the remaining solution using fractional distillation. To show you the diagram, here's your round bottom flask which contains your mixture of ethanol, sulfuric acid and potassium dichromate 6. We've got those anti-bumping granules again in order to stop large bubbles forming. As you heat that mixture, the ethanol vaporizes and will want to escape, but because you're heating under reflux, it will return to that round bottom flask where it continues to be oxidized to form ethanoic acid. And as I already said, that ethanoic acid can be separated from the remaining solution using fractional distillation. Secondary alcohols will be oxidized to form ketones. You're going to be using acidified potassium dichromate 6. The colour change will be from orange to green. So just to show you an example, here's propantuol. It's a secondary alcohol, and here's your propanone, the ketone. And like I said, the colour change will be from orange to green. Those tertiary alcohols will be very difficult to oxidize, so no visible change will be seen when you heat it with potassium dichromate 6. So the solution remains orange. So to summarize, those primary alcohols will be oxidized to aldehydes and then to carboxylic acids. For example, there's ethanol plus that oxidizing agent to form ethanal, the aldehyde, and the reaction condition needed for that is distillation. What about if we take that ethanol, oxidize it further using the conditions of reflux? Heating under reflux will form that carboxylic acid. So there's your carboxylic acid, it's ethanoic acid. So there's the summary of what happens with a primary alcohol. With a secondary alcohol, there's propantuol again. Be oxidized to the ketone. Look, there's the ketone functional group with the two R groups attached. So this is propanone. The following pairs of compounds can be distinguished by simple test tube reactions. For each pair of compounds, give a reagent or combination of reagents that, when added separately to each compound, can be used to distinguish between them. State what is observed in each case. So we have butan-2-ol and 2-methyl-propantuol. So just quickly draw those out. I'm not going to draw the whole thing, but I just want to get an idea of where the functional groups are. So we can see that that's the secondary alcohol. This is a tertiary alcohol. So the reagent we could use is acidified potassium dichromate 6. And remember, with a secondary alcohol, it will go from orange to green. Because that tertiary alcohol isn't oxidized easily, it will stay orange. Or you could write no reaction. What about to distinguish between the alkane propane and the alkene propene? You want to use bromine water. With the alkane, it will stay orange. With that unsaturated hydrocarbon, it will turn from orange to colourless. Propanone, so that's a ketone, is also formed by the oxidation of propan-2-ol. Write an equation for this reaction using O to represent the oxidising agent. It's fine to draw their displayed formula if you find that more straightforward to draw their structural formulae. So let's start with propan-2-ol. It's CH3, CH, OH, CH3. There's our oxidising agent. And then here's propanone. And you're going to produce water as your byproduct. State the class of alcohols to which propan-2-ol belongs. You can see here that that alcohol is a secondary alcohol.